In this video, we're going to discuss logarithmic and exponential form. It's pretty simple. So we're gonna. Well, let me start out with recalling something. If I have, say, 5 squared, I know that is equal to 25. This is writing with an exponent. It's going to be kind of similar to what we do today. So if I have 5 squared, that equals 25. Another way I can write this is the square root. Actually, wait, let's say this. 25 to the 1/2. Remember, that changes to a square root. You can bring that out in front. So 25 to the 1/2 is equal to 5. These both kind of mean the same thing, except for they're in different forms. Like one, we're just going to be changing between logarithmic form and exponential form, much like we changed between an exponent and an exponent with a fraction, or like a square root. So hopefully we know that. This is because x squared and square root of x, those are inverse operations. So by definition, a logarithm is going to be the inverse of an exponential. So if we have a logarithmic function, it could be an inverse for an exponential function. So let's look at a definition. So here, if I had log base b of x equals y, and I wanted to change that into exponential form, I could say b, well, maybe I'll do this. That's the same thing as b raised to the y equals x. So let me actually write down how you would say this. So log base b of x equals y, and it just means it means if I take b and raise it to the y exponent, I get x. Or the question that comes up is b to the what gives me x. So that's what logs are. They're just inverses of exponential functions. So if we have something written in an exponential form, we can change it to log form. And if we have something in log form, we can change it to exponential form. So with that, I'm going to do the first example. It's very, very simple. So write this log in exponential form. So really, we're going to follow this pattern here. But this is something that actually somebody came up with. One of my students, they're just like, this is how I remember it. So to change this into exponential form, you would do b to the y equals x, and to them that looked like a 7. That shape there looked like a 7. So they called it magic 7. So if you want to write in exponential form, you can just use magic 7. 121 to the negative 1/2 equals 1 over 11. So in exponential form, this would be 121 raised to the negative 1/2, and that equals 1 over 11. It's very, very simple. That's all you do. If you have a log, you can change it to exponential form by using magic 7. So there you have that. Hopefully that's really simple, but if you have, let's do another quick example. If you have something like this, and you're supposed to write in exponential form, you'd use magic 7. 5 to the 3rd equals 125. That's it. So then 5 to the 3rd equals 125. It's super, super simple. So that would be exponential form. If you want to go backwards, I'm just going to do it in this video. It's going to make a different video, but we'll just keep it here. Example, 3? If you were given something in exponential form, you can always change it back to logarithmic form. So let's do that. So we have write in logarithmic form. So actually, let me point out some things. Here, let's rewrite this. Actually, I already wrote it. This b right there is the base of the logarithm. This b is the base of the exponent. So the base is always the base, no matter whether you're in logarithmic form or exponential form. So here, if we want to write it in logarithmic form, we just make the base. So we'll say log base 3, because 3 is our base there. And then log base 3 of something equals something else. And so I can read this out loud. 3 to the negative 4 equals 1 over 81. So 3 to the negative 4 equals, so this is negative 4, this equals 1 over 81. So really, I'm still just using magic 7, just backwards. And then you can check it. 3 to the negative 4 equals 1 over 81. 3 to the negative 4 equals 1 over 81. That's all you do to change it back to logarithmic form. It's really, really easy. Okay, I'm done with this video. Goodbye.